All right, welcome back. Today, we are tackling a problem that's pretty much a classic in the world of programming, finding the longest common prefix. Now, it might sound straightforward, but getting this right really shows you know how to handle strings like a pro. So yeah, let's just dive right in.
Okay, first things first, let's get the gears turning with a quick little puzzle. Just look at these three words: flower, flow, and flight. What's the common starting bit for all of them? Go on, take a second. Got it? Just keep that in your head for a moment.
And that little piece you just figured out, that's exactly what we're talking about today. The longest common prefix. It's just the longest chunk of letters from the very beginning that every single string in a list happens to share. It's a super common idea in text processing, and you better believe it pops up in coding interviews all the time. So the big question is, how do we get a computer to figure this out? Well, our first strategy is probably the one you'd come up with first. It's the most intuitive. We'll call it the horizontal scan. I like to think of it as the shrink-to-fit method. It's really straightforward. Here's the game plan. You start out optimistic. You just assume the entire first word, flower, is your answer. Then you move to the next word, flow. You ask, hey, does flow start with flower? No, it doesn't. So you have to shrink your guess. Let's chop off a letter. Does flow start with flow? Still no. Okay, chop again. Does it start with flow? Yes, awesome. So now our new best guess is flow. We take that and compare it to the next word, flight. Does flight start with flow? Nope. So we shrink again. How about flow? No. What about flow? Yes, it does. And since that's the last word in our list, we've found our answer. It's flow. And you know, this whole process of chipping away at our guess, that's exactly what this little snippet of code does. It's a simple loop. It just keeps asking, does the current word start with our prefix? And as long as the answer is no, it just lops one character off the end of our prefix and tries again. You just keep shrinking until you get a match, or, until you're left with nothing. But what if there's a smarter way to do this, a more efficient way? Well, there is, and that brings us to strategy number 2, the vertical scan. This time, instead of comparing whole words against each other, we're going to go character by character, column by column. So the logic here is totally different. We look at the very first character of the first word, which is F. Then we scan straight down. Does every other word also have an F in that first spot? Yes. Okay, great. Let's move to the second character, L. Scan down again. Does every other word have an L there? Yes, they do. Perfect. Now, the third character, O. Wait a minute, flight has an I there. And that's it. The moment you hit that mismatch, you stop. You're done. You know the answer is everything you checked before that point. And this piece of code shows that vertical thinking perfectly. You can see we're looping through the characters of the first word one at a time, but for each of those characters, we do a second vertical check. We loop down through all the other strings just to make sure that character matches in the exact same spot. The instant that vertical check fails, we break out and we have our answer. So let's put these side by side so it really clicks. The horizontal scan is word by word. It has to fully compare flower and flow before it even thinks about looking at flight. But the vertical scan, it's column by column. It checks all the first letters, then all the second letters, and so on. This simple difference is what makes it so powerful. Of course, writing good code is never just about getting the main logic right. It's about being prepared for all the weird stuff, the unexpected inputs. What happens if the list of words is empty? Or one of the words itself is empty? You got to cover your bases and handle those tricky edge cases. And these right here are the big ones you have to think about. If you get an empty list of words, the answer has to be an empty string. What if one of the words is an empty string? Well, then nothing can be common, so again, empty string. And what if there's only one word in the list? Well, obviously, the prefix is just the word itself. A truly solid solution handles all of these without breaking a sweat. Okay, so we've got 2 really solid strategies. But which one should you actually use? This is where we need to stop thinking just about getting an answer and start thinking like an engineer. Which one is actually better? And here is the single most important takeaway. The vertical scan is often way more efficient for one simple reason. It can stop early. Remember our example? The second it saw that the O didn't match the I, the whole process was over. It didn't waste any more time. That early exit can be a massive performance boost. Now, if we look at the performance from a theoretical standpoint, both methods have the same time complexity, this O of S. All that means is that in the worst case, the time they take is related to S, the total number of characters in all the strings. But And this is a big but, theory isn't always what you see in the real world. As the notes say, vertical is often faster in practice. You might also see a third method out there involving sorting, which is pretty clever, but the sorting itself actually makes it a bit slower in most cases.
Let me give you an extreme example to really drive this home. Imagine your words are supercalifragilisticexpialidocious and dog. The vertical scan looks at the S, then looks at the D, sees they don't match, and it's done. One comparison. Finished. The horizontal scan, it would take that gigantic first word and have to shrink it, one letter at a time, all the way down to an empty string. It's a night and day difference in performance.
So really, here's what you need to take away. There are two main powerful ways to solve this. Understanding both of them, the simple, intuitive horizontal scan and the clever, efficient vertical scan, that shows a really deep understanding of the problem. It's not just about getting the right answer, it's about knowing the best way to get there. And that brings me to one last thought to leave you with. We've totally nailed finding the common part at the beginning of a set of strings, but what if that common part could be anywhere in the middle? How would you find the longest common substring, not prefix, among a list of words? Now that's a much trickier problem and a fantastic place to take your learning next. Thanks for joining me.